Hello, this should be a quicker video this week. We're going to be doing comparing proportions between two groups, and this is primarily the ChiSquared test. For it you will need SPSS as always, the data file lap hernia, the co-reading is Statistics at Square 1, Chapter 8, the ChiSquare test, and we're going to show comparisons of proportions between how to compare proportions between two categorical variables, and we'll do this using the crosstabs function. Open SPSS and laphernia.sav as normal, and this is what you should see. So we're going to ask the question, how many patients who had a recurrent hernia had a laparoscopic procedure, and how many patients who had a recurrent hernia had an open procedure, and vice versa is how many patients who didn't have a recurrence have open versus laparoscopic. So to do that, we go to Analyze, Descriptive Statistics, Crosstabs, and we scoot across the two variables we're interested in, which is laparoscopic and recurrent, one into row and one into column, and press OK. And we get the crosstabs output. The first box tells us if there are any missing cases in these two variables, and we can see that there's not. And then the second box is the important one, and it's called a 2 by 2 table, and you may have heard of this before. It has 2 rows and 2 columns, and you can see the rows are recurrence, no and yes, and the columns are laparoscopic, no and yes. And in the table itself are the counts of cases, or in this case patients, corresponding to these two different variables. So we can see that there's 50 patients in total, which we know is correct, and we can see that 15 were done without laparoscopy, were done open, and also were primary hernias. 6 were open but were recurrent, 18 were both laparoscopic and recurrent, and so on. Now, in this situation, I'm particularly interested to see how the distribution of recurrent hernias occurs in terms of whether it was done laparoscopically or not. And so to give me some more information, I'm going to go back to crosstabs and go to cells, and I'm going to add in the proportion in row. So I've ticked row there. So what does this tell us? Well, overall 58% of hernias were done laparoscopically, but if we look at recurrence, 75% of recurrent hernias were done laparoscopically, whereas only 42% of laparoscopic hernias were primary. So is there a significant difference between the proportions of laparoscopic hernias that were done between the recurrent hernias and the primary hernias? That's the question we want to answer. And the most common test that we use to determine this is called a ChiSquared test. Make sure you read Chapter 8 in Statistics at Square 1. This gives you all the information that you need to understand this. The way the test works is to compare the observed counts in each cell with the expected counts in each cell. So what does that mean? Well, if we take laparoscopic no, recurrent no, the observed count is 15. The expected count is determined by multiplying the row total with the column total for that cell and dividing by the table total. So 26 is the row total, multiply it by 21, which is the column total, and divide by the table total, which is 50. So the expected count for laparoscopic no, recurrent no, is 10.9. Of course, we can get SPSS to do this for us, and we go to Analyze, Descriptive Statistics, Crosstabs, Cells, and just unclick row for the moment, just to get rid of row and the row percentage, and click Expected. And here you can see the expected count in laparoscopic no recurrent no is 10.9, which is the same as we calculated with the row and column totals. Now, you don't need to know this, but if you're interested, have a read at Statistics at Square One. The way the ChiSquare test works is using this small formula here. You take the observed for each cell, you subtract the expected for each cell, and you square that number and divide by the expected. And you sum this over the 4 cells within the 2x2 table. Let me just do you one as an example. So the no cell is 15 minus the observed is 15 minus the expected, which is 10.9, and then square that. Oh, where's my square? Hang on, scientific, okay. So 4.1 squared divided by the expected, which is 10.9. And that gives you 1.54. And you do that procedure for each of the cells. So that you would do 11 minus 15.1 all squared divided by 15.1 plus 6 minus 10.1 all squared divided by 10.1 plus 18 minus 13.9 all squared divided by 13.9. And that total is your chi-squared number. But just make it easy and go to cross tabs and statistics and click the chi-squared button, continue, and OK. This adds an extra table to the bottom, ChiSquare Tests, and what we're interested in here is the Pearson ChiSquare Test, which is the top of the table there. So the number is 5.476. So that's the number that you get by adding up observed minus expected squared over expected for each of those 4 numbers. And you use a chi-square table, but we're not going to go into that, with a 1 degree of freedom to show that the chi-squared for this 2x2 table is 0.019. And that can be thought of as the probability that there's no relationship between these 2 categorical variables. So it's very unlikely that they're not related. Therefore, we can say. So I'd like you to go on now and determine the relationship between laparoscopic and gender and recurrent and gender. So are the proportions of males and females getting laparoscopic versus open and recurrent versus open, are they the same? Is there anything to suggest that there's a gender bias, if you like, between these 2 groups? Okay, thank you. Or infer that there appears to be a relationship between the 2 of them. So that's really it for chi-squared. One thing to watch out for, if the expected count in any of your cells is 5 or less, the chi-squared test becomes inaccurate, and you should use the Fisher's exact test, which is down within this table as well. So if the expected count in your 2x2 table is less than 5, use the Fisher's exact test.